This video is on the objective perform and interpret a hypothesis test for a proportion, right, a population proportion, using technology, right, so using a calculator. I'm using the TI-84 Plus Silver Edition on my computer. If you have a TI-83, 84, right, they're very similar. And also take a look at the more instruction, right, to see how they take you through step by step how to do this stuff on the calculator. Right? So click on more instruction and see that. Hopefully it helps you out. All right. So let's take a look at this question. You have Steve listens to his favorite streaming music service when he works out. He wonders whether the service's algorithm does a good job of finding random songs that he will like more often than not. To test this, he listens to 50 songs chosen by the service at random and finds that he likes 36 of them. Use a TI-83, 83 Plus, or 84 to test whether Steve will like a randomly selected song, more often than not, and then draw a conclusion in the context of the problem using a significance level of 5%, right? Alpha equals 0.05. All right, so I'm going to write down all the information we got here, and I'll pull this calculator up later. So what he's testing, the claim here. Remember how you start off a hypothesis test with some sort of belief or thought or claim that you'd like to test. And it says he wonders whether the service's algorithm does a good job finding random songs that he will like more often than not. So if I say P is the percentage of songs or proportion of songs that he likes, a proportion of songs that the algorithm finds for him, I'm not going to write all that he likes, then what he's wondering is this proportion greater than 50%? Does it suggest a song that I'll like more than half the time? All right, that's more often than not. Okay. Now this particular claim here, what he's wondering, does not involve equality. He's wondering if it provides him songs that he likes more often than not, right? The proportions greater than 50%. All right, so then when I'm setting up the null and alternative hypotheses, this is going to be the alternative, that P is greater than 50%. And the null hypothesis is the opposing statement, that P is less than or equal to 50%. But again, you're not seeing this, and this is a totally valid null hypothesis. But very often, as you're seeing in the Newton stuff, we just write down the equality part, the part that we're going to assume that P equals 0.5. Assume that this algorithm is giving me songs that I like as often as it's giving me songs that I don't like, right? That the proportion is equal to 50%. And the significance level, they said, was 5%. All right. Well, then a sample was taken. And this sample was 50 songs, right? So Steve took a sample of 50 random songs suggested by this algorithm and found that he liked 36 of them. So remember, this little x usually represented the number of successes. So the population, so the sample proportion, p prime or p hat, I've shown you both of these. These both mean the same thing, depending on what book you're looking at. The sample proportion is, 36 of the songs he liked out of the 50, which is 72%, right? 0.72. Now, if we were doing this the long way, I would, say take 0.72 minus 0.5, then divide by the square root of 0.5 times 0.5 divided by 50, and find the p-value and all that. I do that by hand or with a calculator or a table. But we don't need to do that. All right. This is the part of the section. This is an objective from this section where I'm showing you how to do this real quickly on the calculator. All right. Remember, you've seen this with z-test for a mean or t-test for a mean. You've seen it with these, how the calculator does these hypotheses tests for you. And it also does a test for a proportion for us as well. So where do I find this? If you hit the Stat button and go over to Tests. Now remember, z-test was when you were testing one population mean and sigma was known. T-test was when you were testing for a population mean and sigma was unknown. So we're not using either of those. Those are for means. Go down to number 5. See how it says one prop z-test? That's one population proportion, right? Prop is short for proportion. And remember, our test statistic, if you've been watching videos or reading, you know that the test statistic for a one proportion test is a z-score, right? You're working with the standard normal distribution. So that's why you got z-test written after here. So I go down to one proportion z-test. Now, this first part, P0, this is what are you assuming P is from the null hypothesis. So we are assuming that P, right, the population proportion, is 0.5. And you can't enter 50. You got to enter these as proportions, something between 0 and 1. Now remember, X, like I said earlier, X is the number of successes in my sample, right? He took a sample of 50 SONs and 36 of them he liked. What was the sample size? 50. And then this prop is, what does the alternative hypothesis look like? Is it a two-tailed test, a left-tailed test, or a right-tailed test? What we're seeing here, it's a right-tailed test that P is greater than 0.5. So I move that over to the last part where it says, prop is greater than P0. And then calculate. And look what comes up, right? So it tells you what the alternative hypothesis is, right? It gives you the test statistic. That's what this Z is, 3.11. But the most important part is the P line. Now it gives you the sample proportion. See how the P hat is 0.72? That's what I wrote on my paper. It gives you the sample size. Those aren't that important. What's the most important here to help us make our decision and make our conclusions is the P line, P value. Now, be careful. I have people make this mistake quite often. Remember, P value is a percentage, a probability, so it can't be greater than 1. The P value given to me here is 9.314 . Then you see at the end that E -4 like that. When you see this like capital looking E thing, this means times 10 raised to that power, times 10 to the -4th power. In other words, move the decimal to the left 4 places. So I take this 9.314, right? This is scientific notation here. Take 9.314, move the decimal to the left 4 places. And I'm getting this as the p-value, 0.0009314. So be careful, pay attention. P-value can't be greater than 1. So if you said, hey, the p-value is 9.3, you're wrong, right? You got this E -4 at the end, meaning move the decimal place to the left 4. So just pay attention to that stuff. So you see the p-value is very, very small. And then what do we do with this? Remember, what you do with the p-value is you compare it to alpha to make a decision about the null hypothesis. Do you reject the null hypothesis or not? Now this p-value is definitely less than or equal to alpha, right? 0.0009 is definitely less than, and if it's less than, it's less than or equal to 0.05. And if that's the case, right, if your p-value is less than or equal to alpha, you reject the null hypothesis. Reject that assumption from the null hypothesis. So going back to the hypotheses, we are rejecting this statement. Nope, not keeping that. I am rejecting the statement that p is 0.5, and then we'd support, we'd accept the other statement, the alternative hypothesis. And this was the claim. So our conclusion, and again, the conclusion you make should always involve the initial claim. Our conclusion is that the evidence supports the claim. Right, there is strong enough evidence here to support the claim. And so Steve wondered if the algorithm, does a good job of finding random songs that he'll like more often than not. Well, according to this sample that he took and running this hypothesis test, he'd say, yeah, it looks like it. Looks like it's doing a good job. It is offering me songs that I like more than half the time based on this one sample. So then he'd be like, yeah, the evidence from this sample supports that statement. That the algorithm does seem to be doing a good job of finding sounds I like more often than not. Okay, so yeah, so like I said, so it's either one of these two. All right, remember we reject the null hypothesis. And then let's read the statements after. The first one, there is sufficient evidence, there is enough evidence to conclude that Steve will like a randomly selected song more often than not. That's exactly what I just said. This one's, there's not enough evidence to say that, but no, I mean, we rejected the null, meaning we lean more toward the claim, which was in the alternative hypothesis. Wonderful. And again, please read the answer explanations. All right, and hopefully watching me do this on the calculator or looking at the more instruction, hopefully all that stuff helps you out when you're doing these problems on your own. And thank you for watching.